A fake error message can hijack your AI coding agent and walk off with your AWS keys. No password stolen, no malware installed, just a bug report. It works about 85% of the time, and in testing it already reached a company worth $250 billion. It's called agentjacking, and if you use Cursor, claudecode, or Codex, the next 10 minutes are for you. Here's what you'll have by the end. You'll understand exactly how one poisoned error takes over an agent. You'll know how to check if you're one of the 2,088 companies already exposed. And you'll have the 3 settings to change tonight so this can't touch you. This isn't theory. A security team built it, fired it at real targets, and watched real agents run their code. Quick context because the whole trick depends on it. Your coding agent doesn't just write text anymore. It reads your tools. Through something called MCP, the agent can pull in your error logs, your tickets, your database, and act on what it finds. So when you say, go fix the errors in Sentry, the agent quietly reaches into Sentry, reads the issues, and starts working. That reach is the feature everyone wanted. It's also the hole. And here's the part nobody designed on purpose. The agent trusts what it reads. To the agent, an error report coming back from a tool looks just as trustworthy as the instruction you typed yourself. It has no instinct that says this data might be lying to me. Hold that thought because the entire attack lives inside it. Now the setup. Sentry is the error tracking tool a huge chunk of the internet runs on. To send it errors, your app uses a key called a DSN. And here's what most people never clock. That key is public by design. It sits right there in your website's JavaScript in plain sight because it's only supposed to let you write errors in, not read anything out. Anyone can grab it. That was always considered fine. What's the worst someone can do with a write-only key? Send you a fake error. Turns out, a lot. Let me walk the whole attack, start to finish, because it's simpler than it should be. Step 1. A researcher grabs your public DSN straight off your site. Step 2. They post a single crafted error to Sentry. No break-in, no login. They're using that public key exactly the way it was meant to be used. But this error isn't a normal stack trace. The message is written in Markdown, formatted to look exactly like Sentry's own help text, complete with a fake section titled Resolution, and inside it a command to run. Step 3 is the part that gets me. Days later, you sit down and tell your agent fix the open issues in Sentry. The agent pulls the list, it hits the poisoned one, it reads a clean-looking line that says resolution, run this command to validate the fix, and it genuinely cannot tell that apart from a real instruction. So it does what you'd expect a helpful agent to do. It runs it, an npassx command, on your machine, with your full permissions. And step 4, that command quietly pulls a package from the attacker's server and scoops up everything in your environment. AWS keys, GitHub tokens, SSH credentials, your Sentry auth token, private repository URLs. All of it shipped off to a stranger's server while your terminal just looks like it's doing the job you asked for. The scariest part to me isn't the cleverness, it's how boring it looks on screen. There's no alarm, no scary pop-up, no password prompt. It's a green check mark on a task you requested 30 seconds ago. You would scroll right past it and go get coffee, and they didn't test this on one lonely laptop. Tenet Security's threat team ran it against more than 100 organizations, and 85% of the agents took the bait. claudecode on a Mac sitting next to live AWS secret keys. Cursor on Windows with login credentials and SSH sockets right there. Codex inside a lockdown build pipeline, sandboxed and still compromised. Mac, Windows, containers, cloud, all of them fell. They counted 388 companies with a DSN you could inject right now. 71 of those rank in the top million sites on the entire internet. One was a Fortune 100 firm worth $250 billion. So here's a 60-second self-check before we go on. Open your site, view source, and search the JavaScript for the word Sentry. If you find a DSN, that key is public. That's normal, but it means you're injectable. Then check your coding agent. Is the Sentry MCP connected? And can your agent run commands without asking you first? If that's a yes, and a yes, you are the exact target in this report. Sit tight, the fixes are coming. And before you blame the AI for being gullible, Wait until you hear what the tool's own makers said when they were told, because that's the part that should actually change how you work. You might be thinking, isn't this just prompt injection with extra steps? It's worse, and the reason matters. Normal prompt injection arrives through stuff you type or paste, so you at least have a chance to spot it. This arrives through telemetry, through a trusted pipe your tools have used quietly for years. It sails straight past your antivirus, your firewall, your endpoint protection, because none of those tools are watching an error log for a booby trap. There's no jailbreak, there's no weird-looking prompt. There's just you asking your agent to do its ordinary job. So what did Sentry actually do about it? They were told on June 3rd. They acknowledged it the very same day, and then they declined to fix the root cause and instead shipped a filter that blocks the one exact payload string the researchers used. Their position, roughly, this is technically not defensible. Here's my honest read on that. They're sort of right. And that is exactly what makes this bigger than Sentry. The real flaw was never one company's error tool. It's that we wired our agents to treat tool output as gospel. Sentry is just the first easy door. Any source your agent reads, your tickets, your emails, your internal docs, your pull requests, is the same shape of risk. Agentjacking is the name today. It will not be the last name for this, okay? What you actually do about it tonight. 3 moves, and none of them need a vendor to ride in and save you. Move 1, turn off auto run. If your agent can execute commands or install packages without you clicking approve, that single setting is the entire exploit. Make it ask. Every command, every time. Yes, it's a little more annoying. It is also the one change that kills this stone dead. If you do nothing else, do this. Move 2. Put the agent in a box, run it in a sandbox or a container with limited file access, and stop leaving long-lived cloud keys sitting in plain environment variables. Switch to short-lived scoped secrets, so even if a token does walk out the door, it's close to useless within the hour. Move 3. Audit what your agent can actually reach. Every MCP connection is a door into your machine. If you're not actively using the Sentry integration this week, disconnect it. And from now on, treat adding an MCP server like adding a real dependency you would review, not a toggle you flip once and forget about forever. None of that is exotic. It's human approval, a sandbox, and knowing what your agent can touch. And that's the real takeaway here. The agents are not the villains, and you do not have to stop using them. You just stop letting them act on your behalf with nobody in the room. Quick recap. A public key, a fake error, and a trusting agent. That is the whole attack. 85% success, thousands of companies exposed, and a real fix that mostly is not coming from the top. Your defense is human approval, a sandbox, and an honest inventory of what your agent can reach. Do those 3, and agentjacking goes from a headline to a non-event for you specifically. If this just saved you from a genuinely bad Tuesday, subscribe. I read the boring security report, so you get the 90-second version that actually changes what you do on Monday. Next, I'm wiring up a coding agent live and switching on every one of these protections so you can see exactly what safe looks like in practice. Same setup, fully locked down. See you there.